So now I want to present a couple of objections or criticisms of the fine-tuning argument. The first one is that from biology today we have a very good, powerful, and well-received view of the development of life on Earth, namely evolutionary theory. However, we don't have a theory, a scientific theory that is, that makes predictions that we can test and be confirmed about the origin of life on Earth. We have good reason to think that at a certain point in Earth's history, there were no living organisms on Earth, and then at a later point, there were living organisms on Earth. And so at some point in the past, somehow, through some natural processes, it seems like non-living material gave rise to living material. But we do not have a scientific theory of that process. And as such, we do not have a scientific theory of life in general. We have a scientific theory of how life developed on Earth, but we don't have a scientific theory of life in general. And so that means the fine-tuning argument, which says the universe has to be set up in a certain way in order for life to develop in the universe, that can't be justified at all because we have no idea of what it is or what the conditions are under which life develops. We don't have a general theory of life. We have a theory of life on Earth. So saying that the universe has to be set up in such and such a way in order for there to be living things in that universe is very premature. We don't have the scientific theory of life that would justify that aspect of the fine-tuning argument. Another aspect of the fine-tuning argument that is dubious is the idea that we, through physics, understand the universe well enough to say, here are the physical constants. Here are the values of the physical constants, and here are the ranges of values for the physical constants if there's going to be life in the universe. The problem with these assumptions about our knowledge of the physical constants of the universe is the following. Physics is currently, and has been for the last 60 or 70 years, split between two major theories. One theory focusing on general relativity, the other focusing on quantum field theory. We have four major forces in the universe that we understand: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. General relativity is a theory of gravity. Quantum field theory incorporates the other three forces: electromagnetism, the weak nuclear force, and the strong nuclear force. But what we do not know how to do is put together our best account of gravity with our best account of the other three forces. When we take general relativity and quantum field theory and we try to use them together, what we end up with is a discovery that these are incompatible theories. The incompatibility between them is a fairly complex and subtle sort of incompatibility. It's not that one says that P and the other says that not P. It's that when we try to come up with predictions and calculations using both of them, we end up with nonsense answers like dividing by zero or thinking that some value is infinite. So general relativity on the one hand and quantum field theory on the other are incompatible, but they're still our best theories in physics right now. General relativity is spectacular for describing what it describes. Quantum field theory is spectacular for describing what it describes. But we know that neither of these theories is a general theory of the universe and its physics. And we need a successor theory to each of these that will have each one as a special case for those particular circumstances, but a unified theory of all the phenomena that we study in physics still is something that humans have not come up with. We have various guesses for how this is going to go. Quantum gravity is one example, but none of these theories are super well developed, and none of them have been shown to be sufficient to derive general relativity on the one hand and quantum field theory on the other, and have independent empirical evidence for them. So to say that we know exactly what the physical constants of the universe are is premature. We have two incompatible theories about the universe and its physical constants, and it's deeply problematic to assume that this information about the universe is sufficient for us to make judgments about what the physical constants are, much less judgments about what their values are, and much less what ranges of values they might have based on other features of the universe. So two major problems with the fine-tuning argument are: we do not have a general theory of life, so we do not know the conditions under which life in general might come about. We have a pretty good idea about the features of life on Earth, but it's an unjustified extrapolation to go from life on Earth to life in the universe as a whole. That's the first problem associated with biology and life. The second problem associated with physics and our two deep fundamental theories that are incompatible suggests that we are also unjustified in making assumptions about which physical constants there are, what their values are, and what range of values they might have in order for the universe to have various features like living things. So the biology is not there yet when it comes to the fine-tuning argument, and the physics is not there yet. Maybe at some point in the future we will have solid, well-developed theories in these areas, and maybe they will point toward fine-tuning. Maybe they won't. We simply don't know.